Turning brown seaweed into bioethanol using modified E.coli. Bioethanol is a type of biofuel that is produced by turning biomass containing fermentable sugars or carbohydrates into ethanol through fermentation. Such biomasses include maize, switchgrass, sugarcanes, and many more. However, these biomasses possess lignin in their cells wall, which make it difficult to process, offering a lower yield. Ground seaweed, on the other hand, does not contain lignin, which could provide a higher yield and make it less difficult to process during the fermentation process. In fact, a study from the Department of Energy found that twice as much ethanol could be produced from brown seaweed compared to sugarcane, and 5 times as much compared to maize, at least under ideal conditions. However, initially there was one issue with the biomass that could stop brown seaweed from being turned into bioethanol, and that was the fact that one of the primary sugars found in brown seaweed, a lignin, was incapable of being metabolized by industrial microbes at the time, so the yield of ethanol was severely limited. However, this was resolved by bioarchitects labs in Berkeley, California, when they spliced genes that were able to break down the lignite from Verbo splendidus, a marine bacterium, into E. coli, allowing for a greater yield. Cultivation process. Brown seaweed can be cultivated by tying seaweed seedlings to a rope and then setting out a plot in the ocean. The ocean provides all the nutrients, so no additional human actions needed. Once the seaweed has matured, it can be harvested and then pre-treated, which includes dewatering, milling, and liquefaction. After which, the seaweed is then put into an oxygen-free environment with a bacterium such as the modified E. coli. In the absence of oxygen, the E. coli will perform fermentation rather than cellular respiration, first going through hydrolysis, then glycolysis, and then alcohol fermentation. This is a diagram of how it happens. Level of development. The biofuel is still in research and development phase because even though it's proven that it's able to be, the brown seaweed can turn into bioethanol, it's still able to meet market prices without sacrificing profits, so further research is needed in order to compete with other fuels options. Cost-effective methods needed in such areas include cultivation and bioprocessing. Carbon footprint. Brown seaweed is considered a blue carbon, which means carbon that's captured from the Earth's atmosphere into coastal and marine environments. However, it's not carbon negative since CO2 is still released during the fermentation process and bioethanol when it burns. So it's much more neutral. Economic impact. At the moment, it's not fully clear what economic impact that brown seaweed can have since it's not commercialized and it's still in development. However, some assumptions could be made from previous bioethanols. That being the price of brown seaweed will increase since biomasses that are available to use as biofuels, market prices tend to increase, such as maize and sugarcane. The price of maize, sugarcanes, and other biomasses could decrease since brown seaweed has been proven to be much more productive and have a higher yield in ethanol in comparison, as well as an increase in competition in the economic environment due to the new fuel option. Communications efforts to the public have been loose since it's still in development, so it hasn't gotten too much communication outside of news articles and media, as well as infographics. Analyzation. From what I've analyzed so far, I think the brown seaweed biofuel has a high chance of becoming the best biological source for bioethanol if it can meet that cost to sell balance that's holding it back from commercialization. I hold the notion that biofuels require that the biofuel requires additional research and funding in order to cross that barrier and become commercialized, which could be accomplished by increasing public awareness of the brown seaweed as a bioethanol and how it becomes more effective compared to other biomasses. My plan of action would be increasing public awareness of the seaweed bioethanol, seek additional funds and investments, research alternative means of harvesting and processing the brown seaweed, increasing research on improving the efficiency of the biofuel, and then finding a secure environment for the biofuel to be deployed. These are my sources.